All right, this is the Geometry Unit 3, Lesson 4 video. Really not much new information in this lesson, just introduces one kind of unique case when it comes to transversal lines. And it basically says that if you have two intersecting lines that form a pair of congruent angles, so we have like this, and we have these are congruent, that means that not only are those congruent, but they're also right angles. So we would say, yeah, okay, these green ones are congruent, but a better way would be to say that they intersect to form right angles right there. So now, then beyond that, we know that if we end up with transversal lines where there's a right angle pair if we know that also these are right angles and that these are parallel, well, that also tells me that all of these are right angles. And in fact, all of the angles in these diagrams are going to be right angles. So that's really just all it is. It's almost self-explanatory that if you end up with right angles and these are parallel lines, then all the rules apply from the previous lessons, and all of these angles would end up being congruent because they are 90, 90, 90, 90, 90, all the same. So really, this doesn't have a whole lot of new things going on. And then this theorem 3.4c says something similar. It says you have these two lines, and they're both perpendicular to this line, and this line's perpendicular. Then again, we know these are parallel. So it goes both ways. So if you know that these two lines are parallel, then you know that a perpendicular line in one will mean a perpendicular line in the other. And if they are both perpendicular to the same line, then those lines have to be parallel. That's really what that's saying. So just have those theorems in front of you, because when you go down here, we're going to have some properties that you need to fill in the blank. So it's theorem 3.4c right here, 3.4a. You just need to use the theorems and look in the notes. I'll post them as well. Same thing here, perpendicular transversal theorem. You just need to fill in the blank. That's really more or less a vocabulary word of using the theorems to fill in the blank of the definition of that theorem. Then we have some proofs. I've told you before, I'll do these proofs here on the videos, and you just need to follow along because these aren't really going to be tested. So we're just kind of getting through the concepts and making sure you guys kind of understand kind of the steps and not the whole process. It says line M intersects line L, and angle 1 is congruent to angle 2. We see that down here, that those are our givens right here in statement number 1. Our given is that information there. Then it says, next, line 1 or angle 1 and angle 2 are linear pair of angles. Well, we see that that's just the definition, right? Those are next to each other. We know that the definition of a linear pair is simply that you have some line with another ray coming off. These are both examples of linear pairs. That's what we have right here. So we're going to say that's the definition of linear pair. So answer choice C. And the next one says to use theorem 3.4a. So we see that right here. So we should go check what 3.4a says. Let's run up here and look. 3.4a was the first one we covered. It says if two intersecting lines form a linear pair of congruent angles, then the lines are perpendicular. So we know that because we have a linear pair here at angle 1 and angle 2, because these angles are congruent, that means that these lines are perpendicular. So that's what we need to be looking for. So we need to look for something about perpendicular, and there we see it in answer choice E. Those two lines are perpendicular. Therefore, the angles are equal to 90 degrees, and that's the definition of perpendicular lines. That's pretty straightforward. All right, moving on to the next one. T intersects L. T intersects L and M. T is perpendicular to L. We see that right there with that little box. And L is perpendicular to M. Okay, so we see these are parallel. These are perpendicular. So we're trying to figure out if we can prove anything about these angles. Specifically, we want to prove that 5 and 6 are equal to each other. So here we go. We have our givens in statement number 1. We have our givens. Then it says T is perpendicular to M, and that's going to be one of our theorems from our lesson. Well, we know that the perpendicular transversal theorem, if we go back up here, said that if oh no, that wasn't it. Sorry about that. In a plane, if two parallel lines are cut by a transversal such that the transversal is perpendicular to one of the lines, then it is also perpendicular to the other line. Well, that's exactly what we have. We see that L is perpendicular to T, so then it also has to be perpendicular to M. So we're going to hop down here and we're going to find perpendicular transversal theorem, answer choice C. Then we say that 5 and 6 are 90 degrees because that's the definition of perpendicular lines. If these two lines are perpendicular, then these have to both be equal to 90 degrees. And then to substitute, all we're doing there is we're proving that 5, the measure of angle 5 is equal to the measure of angle 6 because that was the last thing we needed to prove. So always the last line of your proof is going to be the thing you were trying to prove. And that's it for lesson 4. It's a short one. Finish up the quiz, and then we'll be back on it next week.